Привет, Москва! Спасибо. Меня зовут Max, и я из Австрии. That's basically all the Russian I can speak. So this will be in English, don't worry. But I had 2 years of Russian in school, and I basically learned the alphabet. And that was so hard, it took me 1.5 years, and then I barely had time to learn any other Russian. I'm here to talk to you about today. Sorry, I'm here today. That didn't make any sense. I'm here today to talk about offline web applications. I'm from Austria, as I just said. What you see in the background there, very faintly, that's Vienna, where I'm from. And I work as an open source developer at ThinkMill. ThinkMill is a full-stack JavaScript agency based in Sydney, Australia. Now, just to make sure, I'm from Vienna, Austria. Austria and Australia are not the same country. You'd be surprised how often people mess that up. So ThinkMill is a company based in Sydney, Australia. I'm from Austria. And I work as an open source developer, which means I maintain a lot of open source projects, some of which you might know. My most famous open source project is probably React Boilerplate, which is a React starter kit that has over 10,000 stars on GitHub. The second most famous one is Keystone.js, which is a Node.js content management system, or actually the Node.js content management system. And then I also maintain Elemental UI, which is a React.js UI library, and Styled Components, which is a new way of styling React applications. Now, I like to travel, and I like to travel a lot. My plane to Moscow was my 59th airplane this year, I think. So I've seen a lot of parts around the world. And 2 years ago, I went to Southeast Asia. Now, in Southeast Asia, I went to Cambodia. Cambodia is a country you think about so little that you still haven't realized that that isn't Cambodia, this is. In Cambodia, I went to this tiny island just off of the coast of Cambodia called Koh Rong. Koh Rong is paradise on earth. It's tiny. This is what Koh Rong looks like if you zoom in on a map. Now, there's obviously no scale here, but essentially there's one harbor, there's 2 beaches, and maybe 15 houses, maybe 20 by now. So it's tiny. But the thing is, it's beautiful. It's completely empty. There's no people there. All you have is beautiful beaches, beautiful ocean, lots of nice people, lots of party. It's great. I went there, and I originally wanted to spend like 2 to 3 days there, and then go back to Cambodia and visit the rest of the country. After 8 days, I reluctantly left the island because I had to catch a plane back to Vienna. I didn't want to leave. I just wanted to stay there forever. Koh Rong is amazing. Now, nothing comes without downsides. Koh Rong is paradise on earth, but it only has 2 hours of electricity per day. Because we're in Cambodia, the whole power thing is very well developed. And since it's an island, there's no direct line of power to the island. So the only way to get electricity on there is by a generator. They have this huge generator that they have to power on for the island to have electricity. And because fuel is expensive, they only do that for 2 hours every day. So in the evening, from 6 p.m. to 8 p.m., there's electricity. Otherwise, it's dead. Now, 2 hours per electricity isn't too bad, but that also means that it's only 2 hours of network per day. That's all the internet Koh Rong gets. This island is connected to the internet for 2 hours every day. Now what that means is that at 6 p.m. every single day, people go into the cafe where there's Wi-Fi, right? They go into the cafes, log into the Wi-Fi at 6 p.m., and then they talk to the family. And the other thing that they do is they open all the news articles, but they don't read them, right? They open the articles, read the headline, think, oh, that sounds interesting. So let's screenshot it. Screenshot the first page, scroll. Screenshot the second page, scroll. Screenshot the third page, close article. Next article. That doesn't sound interesting, close. Next article. Oh, that sounds interesting. Screenshot the first page, scroll. Screenshot the second page, scroll. Screenshot the third page, scroll. Screenshot the fourth page, scroll. Oh, that's it. Close article. And so on and so forth. And people do that for 2 hours straight. Everybody sits there with their phones in their hand and goes, screenshot, 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 next article, screenshot, and so on. And why do they do that? Because as soon as the electricity is turned off, and as soon as the network is gone, what they do is they take out their phones and they just read the articles, right? They look at the first screenshot, read the first page, delete the screenshot, look at the next screenshot, read the second page of the article, and so on and so forth, right? Because you only have network for 2 hours every day, you have to be a bit creative to get all of the reading in that you want to read. Now, this might sound like some obscure problem, right? Some people somewhere on an island in Korong with 20 houses, they have this problem of only having 2 hours of internet per day. But I'm sure every single person in here has seen this before. This is what I like to call the loading spinner of death. It's this endless cycle of never-ending agony of waiting for something to load. And you're like, will this load? Will this ever do anything? Like, will anything ever happen? When I live in a very old building in Vienna, right? I live in this centuries-old building in Vienna that has really, really big walls. And every morning when I leave my apartment and I go into the staircase, I lose all my connection, right? It's just gone. That's because the staircase has 3-meter thick walls, right? It's this thick walls, and there's no network can get through there at all, right? And every morning I get out, I walk out of my apartment, I sort of read the latest article on Medium or something, right? Really tiredly, like, oh, it's so early. And then I try to click a link. And every morning I make the same mistake, right? I read the article, I click on the link while I'm in the staircase, and suddenly I go, oh God, no! The internet is gone. No! And then I have to spend a minute in the elevator waiting for the network to come back. You know how annoying that is? Every single morning it happens to me. That's because network coverage isn't there. Now, if you think about network coverage, you'd probably say, for example, in Austria, the network coverage is quite good, right? Wherever I go in Vienna, most of the time I have good connectivity. It's probably not the same in Russia because it's much, much bigger, but you know, in Moscow at least, it's probably relatively good. But the thing is, we will never ever have 100% network coverage. Having 100% network coverage would mean that every single little corner in every single building in the entire country has network connection. Every single tunnel you go through has network connection. That's never going to happen, right? The Hoodie team, who are sort of famous for kicking off this offline first movement, they have this great article where they have a quote in there and they say, geography is non-negotiable. You cannot argue with a mountain to please move the fuck out of the way because you want to read the latest article, right? You cannot argue with geography. You cannot argue with a mountain or with a building, right? You are at the mercy of them. The web, in its very essence, if you think about the web in its very essence is information, right? That's all the web is. All we do is just encode information, send it over the wire as bits and bytes, and then decode it on the other side, and then display it somehow, right? All we do all day long is transferring information from people to people, from machines to machines, right? The web, in its very essence, is just information. The thing about information is that it's the most useful when it's there at the right time. Sounds trivial, right? Information is the most useful when it's there at the right time. Let me give you an example. Imagine if I wanted to take a train from Moscow to St. Petersburg, right? And I sort of look at the train schedule in the evening and I go, oh no, the last train to St. Petersburg left 2 hours ago. So I'm going to have to wait till tomorrow to catch the train, right? That's useful information. That's good to know for me because I don't have to go to the train station to find out that the last train left, right? Very useful information. But imagine if instead of knowing that 2 hours too late, 3 hours ago, my phone would have told me, hey, the last train to St. Petersburg where you want to go is leaving in an hour. So if you want to go, you better leave now, right? That would have been even more useful for me because then I would have had time to catch the train. So information is useful, but it's the most useful when it's there at the right time. Now, we as web developers, as people who don't do anything except transfer information all day long, that's what we do, we need to be there when our users need us. You need to be there when your users need you. The thing is that because network coverage isn't 100% there, this is sometimes hard, right? You don't have full control over the user's devices. You don't have full control over the user's network connection. You have no idea. They might be sitting in Zambia in the Sahara and just like trying to load your page and it's just not working, right? You don't have full control over everything. But there is a lot of things you can do. And very early on, 10 years ago by now, some people realized that having some sort of caching in browsers might be a good idea, right? What if we could cache some parts of our websites offline, allow web developers to tell the browser, hey browser, when the user is offline, display this page, right? And so they built something called app cache. App cache is short for application cache and is a manifest file. It allowed you as a web developer to present the browser a list of files that it should cache, right? So you could say that, so you could tell the browser, hey browser, cache the index.html file, and cache the styles.css file, and cache the bundle.js file. And then when the user's offline, show the cached files instead of trying to go to the network. And that's a really good idea, right? It's quite simple to use. All you have to do is write a file with a list of files. It's not hard to use. And basically, it's perfect, right? Well, no. The issue is that app cache is a douchebag. That's a quote by a man called Jake Archibald, who works at Google, who wrote an article which has that title. It's great. If you use app cache, or if you ever thought about using app cache, read that article. The problem with app cache is that it has a bunch of pitfalls. It has a bunch of huge problems. One example is the cache invalidation in app cache. Now, we know there's two hard problems in computer science, right? Naming things, cache invalidation, and off-by-one errors, right? Those are the two hard problems in computer science. Cache invalidation isn't something that's very trivial to solve. It's a hard thing to do and very much dependent on the app that you use. But what app cache does is just ridiculous. When a user visits your page and they have a network connection and it is cached with app cache, the browser will return the cached files, right? And then you might think, well, a sensible thing to do if the user is connected would be to check if there's new files on the server, right? Have the files that are cached changed, and if so, download the new ones. But that's not what app cache does. What app cache does is it checks if the manifest file has changed. That means that app cache checks if the list of files has changed, which means the only way for your users to get in the new version of your application is to change the list of files that are meant to be cached. It's not enough to change the files. You have to change the list of the files that you want to cache. What? How does that make any sense? Now, you can work around a bunch of these pitfalls, right? So you could, for example, generate a hash based on the contents of the files and put that in a comment automatically, it builds up and stuff. But the basic thing just stands: app cache is a douchebag, and it has a bunch of pitfalls. And that's why a year ago almost, Firefox said, you know what? That was never a good idea. Let's just deprecate it. And app cache has actually deprecated, Firefox has actually deprecated app cache on insecure regions, and it's going to deprecate it eventually on secure regions. And then Chrome went, wait a second, if Firefox does that, that sounds like a good idea. And they said, okay, we are probably going to deprecate this also sometime. Now, of course, deprecating something on the web is a hard thing, so they haven't actually gone ahead and done it. But it's going to be deprecated eventually because it has a bunch of security issues and a bunch of pitfalls, and it's very, very hard to use. And the reason why they can go ahead and deprecate it is because there's a new, better thing, and that is called ServiceWorker. ServiceWorker takes this idea of allowing web developers to give your apps offline behavior and sort of empowers it to be 1,000 times more powerful. Service workers are essentially custom scripts. So by default, a service worker does nothing. Nada, niet, right? Absolutely nothing. A service worker is a JavaScript file that you write, right? You as a web developer write your service worker. And it's a JavaScript file, so you can just go in and do whatever you want in there. Contrary to app cache, where all the behavior is pre-made for you by the browsers, you have full control over the offline behavior for your app. Now that's all pretty abstract, so I figured I'd show you an example. I built this very tiny website, which you can go to if you go to amxs.is/asdk. It's a tiny website. It doesn't do much. All it does basically is just show you some text and a nice GIF. Nothing fancy going on here, right? Just a very simple page. And what we're going to do is we're going to cache this. So if you imagine the right side here being the client and the left side being your server. Now the user with that browser visits your page, and the browser then goes, hey server, I need that page. And the server computes some stuff maybe and sends down an HTML, right? It goes, yeah, sure, I have that page, and sends it over to the client. And then it gets an HTML page, for example, and then the browser goes ahead and passes that, and then it passes the CSS, and it passes and executes the JavaScript. And as it executes the JavaScript, it passes what I like to call the magic line, right? Navigator.serviceworker.register. And we'll get to that. But it passes this magic line which tells the browser to install a service worker. So the browser goes ahead and installs a service worker. Now the special thing here is that this service worker that we have in between our client and our server is completely under our control, right? We can do whatever we want in there. Literally whatever we want, we can do in there. Now, what we're going to do in this example is very simple. We're going to open a cache and then put the files of the page into the cache. And then the next time a new request comes in from to the same page, the service worker is going to catch the request, it's going to intercept the request. We're going to check if the cache has the relevant files, and then we're just going to return the files from the cache so the network doesn't need to be accessed ever. This is very simple caching behavior, right? Nothing fancy going on. What does that look like? Let's take a look into our main JavaScript file here. Now, ignore all the sort of compatibility checks and everything. This is what I want you to focus on. Navigator.serviceworker.register. That's the magic line. And as you can see, what we pass into this function is a path to a JavaScript file. And again, that's our service worker. We write that JavaScript file. It's not some premeditated behavior that we have to use. We can do anything in there. So let's take a look at what we're going to do. This is our ServiceWorker.js file. Now, the first thing we do is just set a cache name, because caches have to have a name, and you can have multiple ones. I just hard-code it, because there's no need to have multiple caches. And then I also hard-code all the URLs that I need to cache. Normally, you would probably do this in a build step or something, but I just hard-code it, because it's a simple example, right? So we're going to want to cache these 4 files, just the HTML file, our JavaScript file, our styles, and the GIF that we show, right? That's all we want to cache. And this is where it gets interesting. The whole Service Worker API builds upon event listeners, so everything is based on event listeners. What we do here is we wait for the install event. As soon as you call navigator.serviceworker.register, the service worker is registered. And then when that is done, this event is fired in the service worker. And now we can do some sort of thing. We can do really whatever we want. What we're going to do in our case is open the cache and then add all the URLs that we want to cache into the cache. That's pretty simple, right? Nothing fancy going on here, an event listener, and then we cache some things. This whole cache API, so this caches.open and cache.addAll thing, that's all custom to service workers. That's a very special API that only service workers have access to. Now then, as a second step, now we've cached all the files that we got, right? Which is cool. But we also need to return them when a user requests them. So we listen to the fetch event. Now the fetch event is very, very interesting. The fetch event happens every single time a request goes out from your page. Every single request from your page is going to pass through that event, right? Every single one. If you do an Ajax request, it's going to pass through there. Loading some fonts, going to pass through there. Everything is going to pass through there. Now that's really powerful, but also really, really dangerous. It's kind of like a man-in-the-middle attack, right? That's why Service Worker is only allowed on secure origins. You cannot use a Service Worker on HTTP. You have to use HTTPS. You should be doing that anyway, so that's sort of a tiny downside, but just something to be aware of. Now, so we listen to this fetch event, and then what we do is we respond to the event that we get with a match in the cache, right? We're going to try and see if we have the files for that request that just came in cached already. If we do have the files cached, we just return them straight to the browser, and that's it, right? At this point, if the user's visited the page before and we cached all the URLs, the user already has all of the files. Now, the issue is what happens if we don't have them cached, right? So what we need to do is we need to basically just fetch the same things. What we do is we clone the request, because you can only use a request once, and we just used it once. So we have to clone it to be able to use it again. And then we just do fetch, right? We just fetch the exact same request that the browser just tried to do and send it to the server. And then we wait for a response. And then if the response that we get from the server is an error, we return that straight to the client. We don't want to cache errors, right? Imagine if your user tries to load something, the service worker goes, oh, I sent off that request and an error came back. Let me cache that error. And then every single time your user visits the page, they're going to get an error. Not very nice behavior, right? So if we get an error, we're not going to do anything. We're just going to send that error straight to the client. The user can deal with it. We don't care about it, right? Now, if we get a valid response, if our response is not an error, we clone the response because we just used it. Again, you can use responses and requests only once. And then we cache the files that we got back, right? So we say, hey, for that request, the next time this specific request comes in, respond with these files that we just cached. And then we're just going to return those files to the user, right? And then the user sees their page normally. Now, the next time they open it, we're going to have the files in the cache, so we can just return them straight up there, immediately over to the user, no need to go to the network. Now, something you might have noticed before is that this uses fetch, which is a new spec, right? As we heard Axel say in the morning, fetch and promises. Service workers only work in browsers that support promises and fetch. They rely on these things being there, so they only work in browsers that have fetch and promises, which is another downside to be aware of. You don't have as good as browser support as with app cache. So we've done all of that. Now let's take a look at what it looks like, right? We go into airplane mode, which means we don't have any connectivity at all. And then we try to open our page again. And surprisingly, it's there. Even though we're in airplane mode, our full page is now cached offline, right? It's there. It's just as if you were online. Now, if you don't believe me that we're really offline, I'm going to try opening the best page in the world, which is my home page. Absolutely the best page in the world, but obviously it doesn't load because we're offline, right? There's this nice dinosaur game. Did you know that? It's pretty cool. So when you're offline, you can play this sort of little dinosaur game, which I'm really bad at. So I died way too early. But so we're fully offline here, right? There's no connection whatsoever, but our page still loads as if it was online, right? It just looks exactly as if it was online. Now that's very basic service worker behavior, right? Mozilla has this very, very great page called ServiceWorker.rs. You can see the URL down there, ServiceWorker.rs. What this gives you is recipes that you can implement. They have a bunch of really, really advanced stuff in there, right? They have things like virtual servers. So you let your service worker pretend that they're the server and return a real response, and then save the requests. And when the user gets back online, they replay those requests to the server, so the state between the client and the server is synced. Lots of crazy stuff you can do. Because it's all custom, there's so much you can do with service workers. It's incredible. This page is a great resource if you want to look into sort of what kind of things can I do with a service worker. Now, as I said, service workers are only supported on browsers that support promises and fetch. So the browser support is a bit meh at the moment. It gets a bit better when you look at it from a usage-related perspective, but there's still a bunch of red in there. By the way, who of you knows the UC browser for Android? Raise your hand. UC browser for Android? Like 15 people in the entire audience, maybe? Which is like a 100. UC browser for Android is huge, right? If you look at this, more people use UC browser for Android than all the versions of iOS Safari combined, all the versions of Opera Mini combined, all the versions of the Android browser combined, right? That's because it's huge in China. Everybody in China, for some reason, uses UC browser for Android. So if you're not already testing your websites on there, please start testing your websites on UC browser for Android. You can just download it from Play Store. So many people use this, and nobody ever tested. I didn't know it existed, right? And then I looked at it, and I was like, holy cow, a lot of people use that browser, and I've never heard of it. So that's really important. Definitely, if you don't take anything else away, please test your apps on UC browser for Android, all right? Now, we can go a step further, though, right? So now we're offline connected, but if you think about a native app, what makes a native app really a native app is home screen capability, right? Native apps live on your home screen. Now, since Chrome 31, I think, and Safari had it first, you can do add to home screen for web pages. So there's this nice menu where you can click add to home screen, and your website is going to live on the home screen of the user. Now, by default, when you do that, and users click on the icon on the home screen, what happens is that it just opens in the browser, right? It's like a bookmark on your home page. Not very useful. But then in Chrome 39, they introduced something called a manifest file. Now, this manifest file has nothing to do with app cache, right? Forget about the app cache manifest. This is manifest.json. Now, this progressive web app manifest, or whatever it's called, is a JSON file where you can control what happens when your users add your app to the home screen. Let's take a look at what that looks like to understand why it's useful. The only thing you have to do in your HTML is add one link, right? So you say link relation equals manifest, and then href equals some JSON file, in our case, manifest.json. Let's take a look at that manifest.json file, because that's where it gets interesting. This is what it looks like, right? We can set a bunch of properties for our web app that it can look like a real app. Now, the first thing we do is we set a name. By standard, it just takes the title of your website, but you can just give it a standard name that works across all pages. And then we have this array of icons. Now, you might be thinking, why is it an array? Why do I need to have an array of icons? But the issue is that different phones have very different pixel densities. And different icons in different sizes look better on different phones, right? So some phone with a very high pixel density will need a very high resolution icon, whereas some older phones with not as high pixel density are fine with a lower resolution icon. So we can specify multiple icons in there to make sure that our icon looks good no matter which phone they're loaded on, right? In my case, I didn't bother with that, right? I have an icon, let's just use that. So we have our icon that will be displayed on the homepage. And then we set the start URL. This can be whatever you want. In my case, I just want the app to open with the index.html file. Then we have the display. And this is interesting because display standalone basically says that when users add your website to the home screen, it should display like a standalone native application. And we'll see what that looks like very, very soon. And then the last thing we say is just that it should be used in portrait because it's not landscape or optimized. I didn't bother with that. So whatever you do, it always opens in portrait mode. So let's see a demo. Again, what we do is we open our website, right? And then we click this add to home screen thing in the options over there. And as you can see, we have the name and the icon there. The user can already see what it's going to look like on their home screen. Now, when they press add, what happens is they get a new icon on the home screen. So if you go back to the home screen now, what you will see is an app, right? The thing is, now when we click on this, it doesn't just open in the browser, right? It's like a real native app. It has this nice splash screen, and then it displays without any browser things, right? It's just like a native app. That's it. Now, the thing is, it's even integrated into the task switcher, right? So you can close it. It's literally as if people had installed a native application, which is great, especially combined with our ServiceWorker, because that means it's offline available as well. Let's demonstrate that for a second, just so you know. Again, we're going to open airplane mode. And then we're going to try opening our now native application from the home screen. And as you can see, it loads perfectly fine, right? Because the ServiceWorker is still running in the background, right? We still have all the files cached. Everything just works perfectly fine. So this now feels like an actual native mobile application. Now, when you look at this, there's still one tiny thing missing, right? It would be nice if the user knew that the app was offline available, right? Because normally from websites, you don't really expect them to work offline, right? It's not a thing that users go and say, oh, that website, oh, that will definitely work offline. No, users don't do that. They don't expect that. So we need to tell our users. Now, this is where it gets a bit more interesting. This is our bundle.js file again. Service workers work with events. I said that already. So what we do in our main bundle.js file that the browser gets is we listen to a controller change event. The controller is essentially the service worker. It's called a controller because there's different types of workers. So a controller change event just means that this event will fire whenever a new worker is installed. In our case, there's only a service worker, so we only have to listen for that. So as soon as our service worker is installed, this event will fire. And then we'll listen to the state change event. Now, a state of a service worker can be one of 5 things: installing, installed, activated, or activating, activated, and redundant. So you can listen to those states and react from your application based on in which state your service worker is in, right? If it's redundant, display the user message, hey, this page is no longer offline available. If it's activated, you say, hey, the page is offline available, right? You can now download this and open it when you have no network connection. So that's what we're going to do. We're just going to tell the user when the page is offline available. We do this by listening to the state change event and checking if the state is activated. If the state is activated, the state that we got, that means that our service worker was just installed. And what we then do is just show a message, and then after 5 seconds, hide it again, because otherwise it gets annoying, right? So we're going to show an offline message, and then after 5 seconds, hide it again. Now, this doesn't work quite yet, because we need to do something from our service worker as well, which is this. All this does is just tell the service worker to tell the client, the browser, that it's activated, right? So from the service worker, we listen to, hey, am I activated? And as soon as that happens, what we do is we do self.clients.claim. Or the client, a client in the service worker context is just the browser, right? It's the document sort of thing. And what we do by claiming a client is sort of telling the client that, hey, we're here for you. We have you, we got you. Don't worry, we got your back. So by doing this, we send this state changed event to our browser. And that's what we react to in our main.js file. What does that look like? Well, again, we have our app, we open it, and as soon as it's cached, it displays this nice message in the top right, page ready for offline usage. And then, users can go ahead and use that app like in any other native application. They can go offline, they can close it, open it, and it's always going to be there for them. So if we click on it again here, with airplane mode enabled, of course it's going to load. Now, something you might notice here, it doesn't display the offline message again, because why would it, right? It's already activated. The activated event of a service worker only ever happens once it's activated, right? And then you can destroy it again and activate a new one, but since we don't activate a new one here, the message isn't displayed again. The main thing that I want you to take away from this talk is that you now have full control over how your app works offline, right? You no longer need to rely on some random app cache thing. With JavaScript, you can control how your app works offline. Imagine you make a real-time game, right? You're writing some sort of real-time online game for phones. And people play it, and they play it in the tram, they play it in the underground, and when they lose connectivity, what would happen with app cache is that they would see the game, but they couldn't actually play, right? Because there's no network connection, which is really annoying, right? That's horrible behavior. But with Service Worker, you can go ahead and tell the client, hey, we just lost connectivity. And you can display a message to the user saying, hey, you're offline, so you cannot play the game because it's a real-time online game, right? You need a network connection. But we have the leaderboard and we have your profile cached offline. So if you're in some random country halfway around the world at a real-time game meetup, you can still show your new friends the leaderboard, and you can still show your new friends the profile, right? You can still show your high score, you just can't play the game. Thank you very much for listening. I hope you enjoy the rest of the conference. If you got, thank you. If you have any questions, feel free to ask me.
Hello, Max. Thanks very much for your talk. I wanted to ask you this one. As we see, iOS doesn't support Service Worker yet. So what do I do as a developer if I want my web app to work offline both on iOS and UC browser?
So that's a very good question. What do you do for the browsers that don't support Service Worker? What I do for simple applications, I just use app cache, right? I use app cache on browsers that don't support Service Worker, and if browsers support Service Worker, I use a Service Worker. Now that obviously only works for simple applications. What you would do, for example, a real-time online game is users who don't have Service Workers just don't get offline behavior, right? You can show that in the user interface. You can check if the Service Worker is available, if that's a thing on the navigator, and then you can react to it. And you can show in the user interface, hey, sorry, you're using an old browser or you're using a shit browser, either of those things, like Internet Explorer. Upgrade to a new browser maybe, or we just can't cache it for you. So the question was, how do we conditionally load the app cache manifest? And you have these HTML comments, right? If the IE, what's the syntax for that? If LT9 something show this HTML tag. You can Google that. There's an HTML tag to conditionally do that for Internet Explorer. I never care about iOS Safari. I'm sorry. I just don't cache offline for iOS Safari. No worries. Any other questions? Oh, back there.
Max, thanks for the talk. I got a simple question. The demo that you showed, what's the best practice to inform the user that he is dealing with an offline version of the app based on the states that you've shown or the events? Thanks.
So that's a very good question again. There's a whole lot of user experience you need to think about when your app is available offline, right? So with Service Workers, things you can do can be very powerful. Mozilla has this recipe on their Service Workers site where what they do is they sort of put the server into the service worker as well. So when you're offline, what they do is they return a fake response, right? So the user thinks they're offline, and then in the user interface, like for example, imagine Facebook, right? Imagine you're offline, the user's offline, and they try to post a new status. What you would do is you would show the post in the feed, but show it slightly grayed out with a message saying, hey, sorry, you're offline, but we're going to sync this as soon as you're online again, right? So that's very much dependent on your app. There's sort of no answer I can give that works for everybody, but generally, optimistically update your UI and then sync back up to the server when a network connection is restored.